Good day, everybody. A special case of this problem was worked at the ARML 2009 chess competition. A gentleman by the name of James Albrecht, MIT alumni, I think, worked it for the case k equals 2, and of course k squared would be equal to 4. Okay, so I noticed that it works for all rational numbers k. If k is all the proof doesn't depend on the number system mainly. I don't think it could be complex numbers, but it certainly works for rational numbers. Hopefully, as this will show. So we're trying to solve for x in terms of k, and again, he did it just for the special case k equals 2, and then k squared would be 4. Okay, so this is fairly straightforward. Log base b of x and b to the x are inverse functions. So if we successively apply this twice, we get this equivalent statement. Okay. And so the given equation is equivalent to just this, okay? And again, that just follows from taking, exponentiating base b twice, okay? Now notice if you get, let's see, right here, you're just using, really this is just a lot of symbol mashing. You're really just using this result, we'll say a to the m raised to the n. This is a very frequent background piece of information on a lot of problems. But if you have an exponential raised to another exponential, it's just that base, the product of the two exponents. And that's very easy to just say. If you have m copies of a, n times, that's m times n copies. All right. So you see we used it twice, going from here to here and also down to here. Again, this is a little odd, but you multiply this 2 against k to the 2a. That's kind of strange to see that. That's why I put the dot there. Okay, so again, it's this rule itself is easy, but sometimes you get these towered sort of exponential expressions, and it's kind of a pain in the ass to deal with it. But once you get it like this, you have the same bases here. So you can equate this exponent k raised to the a with 2 times k to the 2a. Okay, and so that's what we're doing right here. Again, the exponential function is 1 to 1. That means you can equate the exponents like this. And so it's very clear here that if you divide by 2 and divide by k raised to the a, you get 1/2 is equal to k to the a. Again, laws of exponents, folks. Here, this is like if you have a to the m over a to the n, you subtract the exponents because there's cancellation going on. Okay, that's equal to a to the m minus n, of course. Okay, and that's what happened right here. And you can just kind of see what's happening. If you have 2a, sitting directly underneath this, you're just going to get k to the a. Okay, so anyway, we got this. Now we know that k to the k raised to the k to the a is equal to k to the 1/2 now. Right, folks, we just showed that k raised to the a is 1/2, but this is the very same thing as, and I'll write this in here because it's a source of significant confusion a lot of times for people who are just learning. This is k to the 1, right, and 2 right there. But 1 is considered superfluous, and it should be. 2 is the index of the radical. It gets left out. So this is the same as just the square root of k. Okay. And it's equal to x. Sorry, this is just easier to do. Hopefully it doesn't lead to any confusion. So this would be the answer to the problem. A is just equal to root k. And when he worked the problem, when Albrecht worked the problem, he just got the square root of 2 as the answer, his special case. All right, now here's just a concrete example. I told you that k could be a rational number, and so you would get x is equal to the square root of 5/3. Remember, we have x is equal to the square root of k. That's what we just showed. Okay, but the k in this case would be 5/3, right? And so I would, competition, I think they let you just leave the answer this way. a lot of people are fanatics about rationalizing the denominator. If you do that, what would you get? 15, let's see, that's the square root of, so this would be what? The square root of 15 over 3? I think so, yeah. Square root of 15 over 3, if you want to rationalize that, multiplying top and bottom by square root of 3, you get this. So this is the so-called rationalized version of the answer. But in any event, this is just an example of rational exponents, going on. Here's 5/3 and here's 5/3 squared. So anyway, this x equal root k would be the final answer as far as what we're looking for. Good night.